All right, we are moving on to our second session of the morning, looking at more examples, this time from yet another perspective that might be less common in meteorology, specifically forensic meteorology. So I'll let Paul Fremeau take it away.
All right, thank you, Kim, I appreciate it. So yes, my name is Paul Fremeau. Not to pigeonhole myself, a lot of the work that I do is involved in forensic meteorology. I work for a small company based in Reno that's called WeatherExtreme. It was founded by Dr. Elizabeth Austin in the late 90s. And so I'll be talking to you today about forensic meteorology, which for those who are not familiar, forensic meteorology involves usually reconstructing past weather events and explaining those events as they apply to different types of accidents. And so we'll reconstruct the weather as it applies to accidents and explain that to attorneys and sometimes arbitrators and sometimes judges in a courtroom setting. But first, a little bit of background on just who I am. I graduated with my master's degree in atmospheric science from the University of Nevada, Reno, and I've been working for WeatherExtreme since late 2019, so I'm going on 4 years in the forensic meteorology field. I have qualified as an expert in the California Superior Court, so I can testify in front of juries in the state of California. Dr. Austin has been my mentor since I met her late in graduate school, and prior to working with WeatherExtreme, I went through the Pathways National Weather Service internship program, did some work for the Western Regional Climate Center, and also did some work for the Nevada State Climate Office. And I'm going to start off today by talking a little bit about one of my very first assignments, and this involved the case of a pretty sudden dust storm on a farm-to-market roadway in western Texas, a small town called Coyanosa. So this accident occurred in 2015 in the afternoon, and I'll be talking about a few of the challenges that can come up while you're reconstructing a past weather event, some of the different data sources that you can investigate, and here is just a little bit of background on just where this particular accident that we'll be diving into occurred. So West Texas, this is an area that there's some oil prospecting going on in that area, also quite a bit of farmland and that type of work. So this was a multi-vehicle collision, and we're in West Texas, so these were actually pickup trucks that were involved. Based on the witness recollections, there was a rather sudden dust storm that came about, and visibility within the storm decreased to near zero. There were descriptions that witnesses and those parties to the accident had a difficult time seeing even beyond the hoods of their vehicles. And just to give a primer on a couple of the challenges, finding out the actual accident location, which is something that is pretty fundamental to any kind of meteorological investigation. We had difficulties and challenges there from differing eyewitness statements and inconsistency on a police report. And I'll talk a little bit about the different tools that were used in the diagnosis of this accident and the weather factors. So looking here, we have the police report that was associated with this accident. And what I've highlighted are the 3 locations where the accident location was notated. The first was the latitude and longitude. And so this is a pretty standard part of an accident report, whether it's traffic collision or NTSB, National Transportation Safety Board, Aviation Incident Report. And we took a look at the latitude and longitude, plotted it in Google Earth, which I'll show shortly. We also have the accident location. The road on which the crash occurred was FM, which means farm to market, road 1776. And that was consistent with witness recollections as well. Finally, at the bottom, it shows the distance from an intersection or a reference marker. So we know this accident was 0.1 miles to the north of reference marker 370. The challenge there is no database that we're aware of at least for the state of Texas, with the locations of those reference markers. So you would need to get boots on the ground and go find that reference marker if you wanted to find the accident location from that methodology. And the problem with the latitude and longitude on the police report was that that placed the accident on Highway or Interstate 10 and far away from the town of Coyanosa. So we instantly recognized that there was a problem there. I've circled in green where the accident should have been based on all of the witness testimony and the road on which the accident occurred. So we realized we had some work to do before we could even start on the meteorology for this case. So one of the data sets that forensic meteorologists review are witness depositions, which are testimony given under oath by parties to an accident and also by expert witnesses. And so we reviewed with a little bit of help hundreds of pages of deposition testimony, looking for breadcrumbs to help us hone in on the accident location. And after many hours of searching, finally we came across the breadcrumb that would lead us to the actual accident location. And constraining it, there was a witness who remembered that the accident occurred 2 miles from an intersection of another farm to market road. And we followed a few of these breadcrumb trails. Most of them ended in dead ends, but this one finally started to help us out. And so we turned back to Google Earth, found this intersection, and started to figure out ways that we could further constrain the accident location. So I've indicated the location of that intersection here. I'm maybe getting a little bit ahead, but I've located the actual accident location, and it turned out to be 4 miles, not 2 miles. So that required a little bit more time using the technique that I'll describe next, which is using Google Street View, which is a pretty nice database on roadways across the U.S. You get actual roadway imagery going in both north, south, east, west, whichever direction the road goes. They usually have it facing both directions. And so if you have something like an accident site photograph, you can match that up with Google Street View to get usually a pretty good representation of how things were looking. So in case people are interested in how to use this and haven't used it before, this slide explains that. And here is an accident site photograph that we were able to use and pull out a few identifying characteristic features that I would look for then in the Google Street View as I clicked my way 4 miles down the freeway, which takes longer than it sounds. We were able to identify a communications tower, towers in the distance on the horizon, a power pole, a fence, and a turnout. And so we figured out what the direction that the vehicles were traveling. They were moving southbound. This photo was taken towards the north. So that's the direction that I clicked my way through on Google Street View. And after much longer than it took for me to change to this slide, I was able to actually find the match, found the comms tower, found a power pole. Turns out the shape of power poles can be important to make sure that you've got the right location. Some have a triangular shape at the top. I spent a lot of time looking for this. Found the power pole, found the fence, found the turnout. So I was very confident that we had a match. And this was all laying the groundwork before the meteorology could actually begin. But the fun part, which everyone in this room has some experience with, was pulling the meteorological data and starting to figure out what happened. So it turned out, and this was consistent with witness recollections, this was a thunderstorm day in West Texas. And so to really lay the foundation and the groundwork, we pulled a ton of data, synoptic charts, text products, severe thunderstorm warnings, special weather statements, things like that. And I will provide links to where all of these different resources can be found. So we discovered that a building thunderstorm was passing through the area around the time of the accident. And it was a building thunderstorm traveling from north to south. And so this satellite imagery helped to show the judge and the jury the potential mechanism for kicking up this dust storm. We then took a look at the weather radar associated with the storm, and we were able to pick out a gust front. So outflow from the thunderstorm, and we had kind of our smoking gun for what may have kicked up this dust, and we were that much further towards explaining what may have caused the accident. Kind of a fun tool in the software GR2 Analyst, which is used in National Weather Service offices quite a bit. There's a volume render tool, and so you're able to look at kind of ISO surfaces of different types of reflectivity within a thunderstorm and look at the progression. And so we were seeing it looked like the core of this thunderstorm sort of collapsed, and based on that with some sounding data, we surmised that there was likely some outflow and maybe even a microburst associated with this thunderstorm. And we turned to the surface observations to help us out a little bit with that. So we found the nearest weather station to the accident, located, I think it was about 6 miles from the accident. So probably didn't get the full force of the thunderstorm outflow winds at this location, but we were able to see a sharp increase in wind speed with time. We also saw in the temperature and relative humidity data a decrease in temperature commensurate in time. So we were able to see the gust front impacting the region. At that point, our data entered the legal realm, and it was the attorney's job to figure out how this data matched up with their legal theory and how it would impact the case. And this particular case, in this case, our report alone, provided along with the attorney's legal motions, were able to get the case settled out of court. So this case didn't require a jury trial. Here, as I mentioned, are some of the resources that we used. So links to everything that I discussed. Google Earth Pro is kind of a nice tool if people are looking for an easy GIS way that doesn't require a lot of, it's a good initial first program to work with, in addition to the other softwares here mentioned. So that was a forensics case. About a year after I started with WeatherExtreme, we were contacted by a California company in the San Joaquin Valley that was having trouble with their workforce driving through extremely foggy conditions. They get a type of fog in the Central Valley, the San Joaquin Valley, called Thule fog, and it'll pretty regularly decrease visibility below 800 feet, and sometimes down to as low as 50 feet. So nasty visibility, and it can be patchy, and so cars will be driving 65 miles an hour down the freeway, suddenly enter a wall of fog. So that can cause the types of accidents that you see here on the right. So this was a 98 car pileup from the San Joaquin Valley. And our client wanted to avoid their employees being involved in accidents like this. So we were brought on to provide a custom fog forecasting solution and recommendations to this company to prevent their employees from driving through and this was a client requirement. They wanted to avoid their employees driving through sub 800-foot visibility. So that's where we came in. So we used one of our tools. We set up the WRF model to represent radiation fog really well. So we picked the right parameters to represent radiation fog, and we used that along with other. We put that in context using other observations and other weather model data, and kind of merging our reports with with some National Weather Service data to provide a dashboard that we built for our client. And just one look at the dashboard shows our recommendation for that day, the type of fog impact expected, the when the fog was expected to set in and when it was expected to dissipate, along with what we thought they should do. So we were proud of our dashboard, and it was rewarding work because our client gave us good reviews and told us that we helped improve the safety of their workforce. So definitely rewarding work. But as I'm sure many of you were expecting, it's actually a very difficult forecast to find a verification data set to see just how well we were doing. We would get anecdotal evidence from our client on how well our forecasts were performing. But one thing that really surprised us was the limitations of the area webcams, because we would have days where we were seeing on webcams, they were completely fogged out. It looked like almost zero visibility. And our client, when we reached out for reports on how our forecast did, they would let us know their employees didn't report visibility impacts. And so that was alarm bells were going off for us. We eventually realized that the height of the cameras matters. Sometimes the cameras were far up above the freeway, in the cloud, in the very low cloud. There were different zoom levels on the cameras that were causing difficulty in resolving. Basically, the cameras were working differently than the human eye. Camera focus became an issue. So that was an important limitation for us to realize and take into consideration as we forecasted. The best verification data set were the aviation weather stations, the AWOS and ASOS at area airports, but of course those were not in most of the locations that we were trying to forecast for. And so we didn't have verification everywhere that we wanted it, and that gave us some good hindsight and a wish list. So one big item on the wish list, and I'd be interested in hearing from this group. So Caltrans, the California Department of Motor Vehicles, has a visibility sensor network, and the data is not publicly available, despite all of our efforts to try to get a hold of that data. Despite being publicly funded, we were not able to get that sensor data. So that's something on our wish list for future contracts. In hindsight, we would have worked with our client to install visibility sensors themselves, because they owned a lot of land. This was an oil and gas exploration type company that we worked for, and so in hindsight, that's what we would do. And these items likely would have led to a better verification data set, which would have been of interest to us. On a related note, I'm interested if anyone in this room is looking for a project. I'm just going to pitch an idea. A very robust webcam imagery archive would be of great value to a lot of forensic meteorologists and probably to a lot of other applications. So project idea has been pitched. A couple of useful products for fog. We really love this false color imagery, daytime cloud phase and nighttime microphysics, and the Sierra slider offers a little bit of an archive. And so you can, instead of having to do your own band combinations via programming, you can actually get these directly from that site. So we really enjoyed that. The high resolution rapid refresh visibility forecasts are often very good. And so that was something that we used quite a bit to compare with our own WRF forecasts. And then finally, the National Weather Service office in Hanford has a fog severity index where it's model output, and using a color scale, they show the visibility impacts that are expected hour by hour. So if anyone's traveling through the San Joaquin Valley in the winter during fog season, that's a nice resource for planning ahead. Which brings me to my final example of the day, back to forensic meteorology. This was an instance of a building collapse that occurred last year in Clark, South Dakota. And in this particular case, we were hired by the Century Select insurance company subrogation department, which I'll define. And we were hired via an attorney to help figure out the cause of this building collapse. So insurance company subrogation departments are a branch of the agency that's their task is to figure out if someone else is liable for a loss. So in this case, for example, in a building collapse, they might wonder how well was this building constructed? Was a construction company negligent in constructing the building, or was this purely and as they call it, this is a legal term, act of God, that caused this accident. So to get started, I was provided with the address of the loss and an approximate time frame of the loss, and they wanted to know was there significant weather involved? What were the magnitudes, or what was the magnitude of the weather impacts that influenced the building collapse? And so I set in to review the radar and the satellite loops for that time frame to try to start honing in on just what had happened. And just another shout out to GR2 Analyst. That's where the graphics came from above, which I'll get into a little bit further. So the satellite imagery, I believe, was the first thing that I looked at and was able to quickly see what appeared to be a thunderstorm with pretty high cloud tops in the region, and this helped me to narrow in the times that I would investigate for the next rad data. The weather radar for this particular location was about 50 miles away, which really isn't that bad, especially for the planes. But the beam height at the location of the incident was at about 4,000 feet, and so we were missing some of the lowest level winds for the accident location. I also searched for any severe thunderstorm warnings, tornado warnings, other special weather statements that were issued by the National Weather Service office, and I did a search of the NOAA storm events database and looked for local storm reports to try to match up with this incident. And probably the most useful graphic that I was able to make for this case was overlaying the incident location with the local storm reports and the weather radar data. And I was able to match up the approximate time of the incident with the local storm reports, which matched up, which showed that there was widespread reports of wind damage through the area. So widespread gusts to over 60 miles per hour. In addition to at least 2 different buildings that were destroyed, assuming that that they were not duplicate entries in the local storm reports, and then also 1-inch tree limbs broken and shingles blown off of a home. So the next step was to take a quick look at the velocity data, see if there were any telltale tornadic signatures. And while there definitely was no definitive sign of a tornado, it was pretty difficult to say that we could rule it out completely. There was just a little bit. I wonder if my mouse is showing. There was like almost just the faintest suggestion of a velocity couplet that popped up for a single frame and then disappeared again. So nothing definitive. Nothing was definitive on the other dual pole products either. But based on what we know can happen, gustnados, QLCS spin-ups, we decided that we couldn't fully rule out a tornado. Interestingly, the severe thunderstorm warning for this particular storm was issued after all of those local storm reports that we showed. So it seems like the warning was issued a little bit on the later side. Not that it would have prevented the building collapse, but we had sort of converged on at least the fact that there was significant weather in the area. The storm that caused the damage or influenced the damage prompted a severe thunderstorm warning, and the insurance company opted to pay out this particular claim and not go after the building manufacturer, just to kind of wrap up what had occurred. And a product that I enjoyed using for this case, in addition to the local storm reports, was the NOAA Storm Events database, which you can use, and you can download a CSV with the latitude, longitude points of different types of storm reports for an event. And you can then pull those directly into mapping software. So I found that pretty helpful. And beginning to wrap up, some of the, hopefully the takeaways for this storytelling day, you can use data from multiple domains to corroborate and strengthen your conclusions. It's surprising what data sets can mislead, including sometimes police reports, sometimes eyewitnesses, which can be surprising. You'd expect eyewitnesses would be the best source of information at times. And even cameras can be misleading. I have a little bit of a wish list. I would love it if someone could come up with a webcam imagery archive that's robust that we could use for forensic meteorology investigations. And then finally, overlaying related data sets can help to put your data in context, see if you're looking at something interesting, see if you're looking at something common or unique. And with that, I think I also am not sure if I've gone over time. Okay.
We're getting a theme here. here. Overlay multiple data sets to get more information about the story. So we do have time for a few questions, if anyone has them either in the room or online.
Yes.
I'm curious, so where do reanalyses fit in, like forensic meteorology? Because I've seen a lot of work looking at like vector environments of reanalysis products, and yet that's also based off a model. So can you use that as evidence in court, or do they just want to see pure observations?
When we have the ability in the budget, we'll use reanalysis data sets to try to recreate the conditions using WRF. It's a weather model, so we do try to downscale using WRF to assess out exactly what may have happened. But in observation, in environments that are not observation rich, sometimes we will use reanalysis data to try to at least give us the general weather pattern in conjunction with other data sets to figure out what weather may have influenced an accident.
In the last case, if you had like a proxy sounding, looking at what was the downdraft potential, or you would say, yeah, tornado is not likely in this situation.
Mm-hmm. So yeah, we will a lot of the time pull a high resolution rapid refresh model sounding, or a few of them, and then analyze those using RayOb or another analysis tool to help us understand what the environment would have been. So that's definitely something that we do. Yes, sir.
Is there anything online? I don't want to jump. Okay. I wanted to address your point poke question about webcam imagery, and I'm gonna, this is actually something I'm also very interested in. We have a project called SAGE, which actually does a lot of machine learning on imagery to kind of turn cameras into instruments, looking at cloud motions, looking for water inundation in cloud images and so forth. One challenge that we face with this is privacy, because people are also in camera images, and the way we've been getting around that is actually running our algorithms at the edge and only ever sending back information about the image rather than the image itself. So I think if anyone was ever to come up with an archive like that, it would either need to be a meta archive, like here is all the places you can get it from, or be somehow dealing with anonymization of individuals inadvertently caught as images, especially when they might be used by forensic meteorologists who talk to lawyers.
Yep, absolutely.
So I know you're talking about sort of like some of the eyewitness testimony or some of that conflicting. So do you consider just I guess how do you deal with where like the weather data conflicts with eyewitness accounts and stuff like that? Like what do you treat as truth? Because like you were saying, like the radar, like I mean that was like above like 4,000 feet or so. Like our observations are always limited as well as our models and stuff like that. Like what's that like sort of deciding like what is truth, especially in like a court-like setting?
It can be tricky. I think that when you use your data and the confidence of your data to weave a story, as we were learning earlier today, that can help to kind of it can be used to explain what the weather may have been, and if you can explain why maybe a mechanism that an eyewitness might be misremembering, or some of the tricks and tools that are more on the attorney side are a little more insidious. But for example, sometimes we will figure out where the sun and moon were, and we can show just how little an eyewitness might actually truly remember about an actual accident, and just kind of show subtly that data can sometimes sometimes the concrete data needs to be trusted, and we find subtle ways to show that.
Any questions online? All right, let's thank Paul again.